welcome to MrCScience.com's video on predicting acid-base reactions. In this, we're going to talk a little bit about how to tell what the products of an acid and base reaction are going to be. So your book offers a list of 8 common acids. Walk through these: hydrochloric acid, hydrobromic acid, hydrofluoric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, and acetic acid. So these are all acids. You can tell often by the hydrogen at the beginning, so it's a donor. These 4 are simple. So when we drop those into an aqueous solution, what's going to happen is that hydrochloric acid will donate its hydrogen ion to become as an acid should be, and it'll leave a chlorine ion. All these will do the same. We'll be left with a bromine ion here, a fluorine ion here, and a nitrate ion here. Now these 4 are a little bit different. They have multiple hydrogens. They're going to be what's called polyprotic acids. Remember, protic stands for proton, and acids are a hydrogen ion donator or a proton donator. So these have the ability to donate multiple protons. So what will happen with sulfuric acid is it will donate 2 hydrogen protons and leave you with a sulfate ion. Phosphoric acid will donate 3 hydrogen ions and leave you with a phosphate ion. Carbonic acid will donate 2 hydrogen ions and leave you with a carbonate ion. And finally, acetic acid is a little bit different. You got the 4 here, but acetic acid is really just happy donating 1 hydrogen ion and leave you with an acetate ion. So this one you're going to kind of have to remember that this one's different, although generally you're really only going to see these 8 acids, and so just remember that these 3 are polyprotic. So anytime you see multiple H hydrogens in front, remember it's polyprotic. Acetic acid is one difference. It's only going to donate 1 hydrogen ion. Okay, there are really only 2 types of bases. Let's give an example of the 2 different types. Ammonia, is a base, and sodium hydroxide, our Li, is a base. Difference is this OH group. Remember, an OH group is called a hydroxy group. You have your hydroxy bases with the OH group in them. Potassium hydroxide is another one. Magnesium hydroxide, I'll have to double check if that's I think it's an OH2, could be an OH3, are all hydroxy bases. Anything that doesn't have a hydroxy acts as a base, as a hydrogen acceptor, is a non-hydroxy base. Let's talk about the hydroxy bases first. So if we take a hydrochloric acid and let's add a hydroxy base of potassium hydroxide to it, what are the products going to be? Well, we know that hydrochloric acid is going to donate that hydrogen ion, and it's going to leave a chlorine ion behind. Now, before we deal with this, then let's look at this. This is potassium hydroxide. This is an ionic compound. It's got a metal in it. Potassium is a metal. So potassium is going to, just when it becomes aqueous, it's going to naturally form potassium ions and hydroxy ions. Now, this hydrogen is going to naturally go with our hydroxy ions. So it's going to produce water, H2O. Hydrogen plus hydroxy is water. What's left over is an ionic compound of potassium plus chlorine. Now, ionic compounds, we don't like to write them out like this. Generally, we like to write them together. This is what we call a salt. Ionic compounds in chemistries are salts. So we're going to write it out. HCl plus potassium hydroxide, so a hydroxy base will give us water. and a salt, in this case, potassium chloride. Okay, let's look at one other one quick. Let's take sulfuric acid, H2SO4, and let's add lye, sodium hydroxide, something that we use. Now, again, we got a hydroxy base, so this is going to donate its hydrogen. In fact, remember, this is polyprotic, so it's going to donate 2 hydrogens. But a hydrogen is going to combine with the hydroxy here, so again, a hydroxy acid-base reaction with the hydroxy base will give us a water, H2O, and it'll give us a salt, in this case, sodium sulfate. Sodium has a positive 1, this has negative 2. In order for this to work, we're going to need 2 of these, and it'll generate 2 waters. So, okay, so hydroxy bases in an acid and a base reaction always give us water and a salt. Okay, now what about non-hydroxy bases? So if we take our non-hydroxy base, that looks terrible. And let's add hydrochloric acid. So we're going to take our ammonia, we're going to add hydrochloric acid. And what's it going to give us for this? Well, I know again, the acid is going to donate that hydrogen, which is going to leave a chlorine ion behind. So because this is all covalent bonding, it will not form ions. What will happen is actually the ammonia will pick up the 4th hydrogen, gaining a positive charge. Ammonia will pick up the 4th hydrogen, gaining a positive charge, becoming ammonium. And what will be left over is chlorine ions. So this will form ions. So let's do something similar. Let's take our here. Let's do a harder one. Let's do our phosphoric acid. And let's add that to ammonia. And what are the products going to be? Okay. Again, this is going to donate all its hydrogens. So really all that's going to be left of our acid is its ion. Now, this hydrogen is going to go to our ammonia and become ammonium, NH4+. Now you'll notice that we have 3 hydrogens here. So we're going to have to add those 3 hydrogens to 3 ammonia, which will give us 3 ammoniums. And now everything should balance across. And you can see you got your 3 positive charges, your 3 negative charges, everything balances out. So non-hydroxy bases will combine with acids and leave you with ions. So if that doesn't make sense to you, feel free to contact me at mrc@mrcscience.com. Thank you.